everyone, thanks so much for joining this video. Today we're going to be learning about enthalpy changes, and here are our learning objectives. So we're going to explain that some chemical reactions are accompanied by enthalpy changes that are exothermic or endothermic, and then we're also going to construct some enthalpy profile diagrams, and then we're going to explain about activation energy. We'll then go through the terms of standard conditions and states, enthalpy change of reaction, formation, combustion, and neutralisation. And we're also going to learn how to determine the enthalpy change directly from using experimental results. Firstly, we're going to look at the two different types of reactions. Firstly, we're going to look at the two different types of reactions. So the first one is an endothermic reaction, and this is a reaction that absorbs heat and cools the surroundings. And then we have the exothermic reaction, which is the opposite. So it's a reaction that gives off heat and warms the surroundings. When we talk about enthalpy change, we just mean a change in the heat energy content, which is measured at constant pressure. These two diagrams are called energy level diagrams. And on the left, we have the exothermic, and on the right, we have the endothermic. So with the exothermic, the reactants start off with more energy than the products. So that's why the energy is released, where the red arrow is. And so we say that the enthalpy change is negative. So enthalpy change we actually denote by writing a delta and capital H. And so this delta H is negative, because the change in heat energy is negative. And then for the endothermic reaction, the reactants start off with less energy and the products have more energy. So that means the energy is absorbed. Activation energy is the amount of energy which is required for the chemical reaction to take place. So it's actually the minimum amount of energy that we have to have before the reactants can react with each other to create the products. So the first standard enthalpy that you need to know is the standard enthalpy of combustion, and this can be written like this as a short form. And the definition of this is the enthalpy change, so the heat energy content change, when 1 mole of a substance is completely burned in oxygen with all reactants and products in their standard states, and when we measure at standard conditions. Now, when we memorize these definitions, we have to get the wording completely right. So you need to remember that it is 1 mole and it's completely burned in oxygen. So it undergoes complete combustion. So carbon monoxide and carbon will never be formed like they are in complete combustion. And we need to remember that we combust in oxygen like usual, and that all reactants and products are in their standard states. The second standard enthalpy is the standard enthalpy change of formation. And like the one for combustion, it looks quite similar, but there's an F instead of a C. And the definition of this one is the enthalpy change when 1 mole of a substance is formed from its constituent elements with all reactants and products in standard states and with everything measured in standard conditions. So the thing to remember with this one is that 1 mole of a substance is formed from its constituent elements, which just means the elements it's made out of. So for example, sodium oxide is made up of sodium and oxygen. So we need to remember that 1 mole of this is formed, and all of these reactants and that product, they're all in standard states. So this is an acid-alkali reaction, and this forms the sodium sulfate salt and water. And the standard enthalpy change of reaction is minus 114.2 kilojoules per mole. And this means that 114.2 kilojoules of heat energy is released for 1 mole of sulfuric acid reacting with 2 moles of sodium hydroxide. And this negative means that it's an exothermic reaction because heat energy is being released. So basically the reactants are losing energy. This second equation shows the same reaction but with half the moles of each of the substances. So we see that the enthalpy change of reaction is half that of the first one. The fourth enthalpy change that you need to know is the standard enthalpy change of neutralisation. And this is the enthalpy change when 1 mole of water is formed in a reaction between an acid and an alkali under standard conditions. And it's really important to remember all the keywords. So it's 1 mole of water being formed, and we're mixing an acid and alkali. So an acid and alkali normally make a salt and water. So when the water is produced, we only produce 1 mole of it, and that's how they measure the enthalpy. So that's the standard enthalpy change of neutralisation. Now we're going to look at some questions. So feel free to click off the video and try them out for yourself first, or you can just follow along with me. So we'll start with question 1, which is telling us to write out equations for the standard enthalpy change of formation. So first we have ammonia, and ammonia is NH3. And so the definition of the enthalpy change of formation is the enthalpy change when we form 1 mole of a substance from its constituent elements in their standard states. And so we're forming 1 mole of ammonia. So ammonia is made out of nitrogen and hydrogen, and they both exist as diatomic molecules, so 2 nitrogen atoms, and they're both gases. So we add together nitrogen and hydrogen to form ammonia, which is also a gas. And we need to remember not to change anything about the ammonia because we're only forming 1 mole, so we can only change the numbers of these two. So now we come to balancing the equation. And so we have 1 ammonia here, which means we need 1 here, but we've got 2, so we must have half of a nitrogen. And then we have 3 hydrogens here and 2 here, so we must have 3 over 2 hydrogens. The next question, bromomethane, which is CH3Br, and that's a liquid. That's made out of carbons, which is a solid in its standard state, hydrogens, which are gases, and also bromine, which is also a gas, and that's also a diatomic molecule. And this forms 1 mole of bromomethane, which is a liquid. And so now we balance the equation again. So we have 1 carbon and 1 carbon here, so that's fine. And then we look at the hydrogen, we've got 3 here and 2 here, so we must have 3 over 2 hydrogens. And then we have 1 bromine here, but 2 here, so we have half the bromine molecule. For C, we're trying to get the standard enthalpy change of formation of sodium oxide. So sodium oxide is made out of sodium, which is a solid, and also oxygen, which is a gas, and is also a diatomic molecule. And we're forming 1 mole of sodium oxide, which is a solid. So now we balance the equation again. And we see that we've got 2 sodiums on this side, so we must have 2 over here. And we've only got 1 oxygen here, so we must have half an oxygen molecule on the left. For the second question, we're asked to write out equations for the standard enthalpy change of combustion. And the definition of standard enthalpy change of combustion is that 1 mole is completely burned combusted in oxygen. And again, we have standard states and standard conditions. So for the first one, we have hydrogen. So that means that we use 1 mole of hydrogen in its standard state, and we completely combust it with oxygen. And when we completely combust hydrogen, we form water. And that's a liquid in its standard state. And now we have to balance. So we think, okay, we're only using 1 mole of this, so we can't change the number in front of the hydrogen. So we've got 2 hydrogens here, and we've actually got 2 hydrogens on the right, so that's fine, we don't need to change anything. But then we've got 2 oxygens here and 1 oxygen here. So we must have to have half an oxygen here, because otherwise if we change this, so say we change this to 2H2O and kept this as O2, then we would have to change this to 2H2s, and we can't do that because we're only burning 1 mole and not 2, so this would be wrong. For B, we're using 1 mole of sodium, which is a solid in its standard state, and completely combusting it with oxygen, which is in its standard state as well. And then we're forming sodium oxide, which is a solid in its standard state. And so we use 1 mole of this and completely combust it with oxygen to form this. And now comes the balancing again. So we're using 1 of this, so we must have half of these sodium oxides. And then we look at the oxygen, so we've only got half an oxygen here, but 2 here. So we must have a quarter of these oxygens to balance it with this half of an oxygen atom. And then for C, we have ethanol, so we're burning 1 mole of ethanol, which is a liquid in its standard state, with oxygen, and this forms carbon dioxide gas and water. So now we balance it again. So we've got 2 carbons here, so we must have 2 carbon dioxide molecules, and then we have 6 hydrogens here, so we must have 3 water molecules, and now we balance the oxygens. So we've got 4 here plus 3, that's 7 oxygens, and then we've got 1 here, and we've got 2 here, so we must have 3 oxygens. So that makes 7, which is the same as this. For number 3, we're asked to write equations for the standard enthalpy change of neutralisation. And if you remember that the standard enthalpy change of neutralisation means that 1 mole of water is formed, then that should help us. So for A, we're adding hydrochloric acid, which is aqueous, and potassium hydroxide, which is also aqueous. So with these reactions, all of the reactants will always be aqueous because we're mixing an acid and alkali to form the water.